Solving systems of linear equations by matrix methods. So in order to solve the linear equations, we have various methods in which or by which we can employ the matrix. So what we are going to discuss today is called the Gaussian elimination or GJ Gaussian Jordan, or also you can call it as the augmented matrix and the echelon form solution of the linear equations. So the first thing first is, whenever we have the linear equations, what does it mean? The linear equation represent y equals mx plus c or ax plus by plus c equals 0. So what is it? This is the equation of line. These two are representation of line. So whenever you are being told that you have two equations and you need to solve it, that essentially means there are two lines intersecting somewhere, and that intersection point falls on both the lines, and that is the solution for both these linear equations. This is the x and y. You can call it as the point on the Cartesian coordinate system. So the augmented matrix first we have to form in order to solve this linear equation. So how to do this? Let me write this equation and tell you step by step. 3x minus y equals negative 9, x plus 5y equals 3. First thing is you have to make a matrix. What is the coefficient of x? It's 3 and 1. What is the coefficient of y? Negative 1 and 5. So now you have to write the coefficient of y. Now, equality. The constants on the right hand side, you have to write it here, negative 9 and 3 in this case. In between you have to make a line. You have to draw a line that is called a vertical bar. And this vertical bar is actually the separation of the columns of the matrix into two groups. First one is coefficient, the second is constants. So whenever we are going to solve this linear equation, we need to know certain matrix row operations. We already know the properties which we can apply on determinants. So on the light or in view of that, whenever we are solving the system of equation, if we exchange the position of two equations, it doesn't matter. Why? If you have two lines, if they are parallel, they won't give you solution. But if you one line you draw first, second line you draw second, or second line you draw first and first line you draw later, the intersection point will remain same. Okay, so if we exchange, it won't affect. Next is, if you have an equation, for example this one, 2x plus 3y equals 5. Now I tell you to multiply with any scalar, for example 2. It will be 4x plus 6y equals 10. Now 2x plus 3y equals 5 and 4x plus 6y equals 10. They both are same. They have no difference. Okay, so this augmented matrix which we are going to form just now with an example, this is just a shorthand way to represent that what is on the left hand side, what is on the right hand side. We have x and y on the left hand side, the constant on the right hand side of the equation, and then we need to solve it in terms of x and y. So 3, 1, minus 1, 5 coefficients, minus 9, 3 the constants, and they are separated by a vertical bar. This is called the augmented matrix. We'll take an example of two variable. So we are using the row operation to solve a system with two variable. We have two variable x and y. So essentially you have to find out the value of x and y, but not by the trivial method or the traditional method. We will use the method of GA, or you can say GJ or Gaussian elimination. First thing, you have to make an augmented matrix. So 2 and 3 is the coefficient of x, 3 and 2 is the coefficient of y. Then constant is negative 1 and 1, and they are separated by a line. This is our augmented matrix which we just discussed just now. First thing is, we have to make the leading term of the first row as 1. Why? You'll just see. Why? Because we are going to form the echelon form or echelon form, some people say, but it's as basically echelon form. So the first leading term of the first row has to be 1. How to make 2 as 1? Multiply it by 1 by 2. So what we are trying to get is that everything on the left of the vertical bar, the diagonal should be 1 and the terms below this line should be 0 or diagonal should be 0. So how to get the 0? First of all, we need to start with the 1. Every line, every row should have zeros and then a 1. So a 1 with leading 0, the 1 should come below the 1 of the above row, right? So we are multiplying the first row by 2, 1 by 2, just because we want to have 1. So first row multiplied by half gives you 1, 3 by 2 and negative 1 by 2. So whole row will be affected. Now second thing I told you that this 3, we want 0 here because the 3 after 2 will be made as 1 later, but we have got the 1 in the leading, the first row 1 we have got. So we'll use this row to get 3 as 0. So we'll multiply the first row with 3 and better is to multiply it with negative 3 and then we add. So multiply the first row with negative 3 and then add with row 2. So what we are going to do is row 2 is changed to row 2 plus negative 3 into R1. Okay. So now we will get 0, first leading 0 in the second row. And as I said, 1 in the first row, then we can have a 0 and then we have 1 in the second row, then we have 0, 0 in the third row, then 1, like this we proceed. So in order to get a 1 here, see, first of all what we have done, we are just doing this R2 plus minus 3 into R1 and then we added. So what do we get? 0 minus 5 by 2 and 5 by 2. So I just told you we got 0. Now this negative 5 by 2 has to be made as 1 because we want the echelon form. So in order to get minus 5 by 2 as 1, we have to multiply the second row by negative 2 by 5. So 1 leading, then the second row will have 1 below, means you can say at the diagonal of the first 1. The below 1 will be 0. So row echelon form is basically matrix which is satisfying the condition that the leading entry is 1. The first non-zero element in each row called the leading entry, which you see here also, is 1. And each leading entry is in a column to the right of the leading entry in the previous row. So you see 1 below is on the right of the above one. Even if you get third row, the 1 should be below or and right of the second row 1. So what we are doing is multiplying it by negative 2 by 5 and you get a 1. So now this is not done. This final form is not the solution. People say minus half and minus 1 is the solution x and y. No. We have to make an equation. So 1 into x plus y into 3 by 2 equals minus half is the first equation. X into 0 plus y into 1 equals minus 1 is the second equation. So because the first row corresponds to x, first column corresponds to x, second column corresponds to y, and the right one is the constant. So we'll make an equation here. So y equals, what is the value of y? It's negative 1. Now with this solution, because now we have y, now we can get an x because we have a proper value of y. That is why we made and we formed the echelon form. And now you understood why we had the echelon form. Because now the second row will give you the exact value. So just put y equals minus 1 in the first equation and you get x as 1. So the solution has to be written like this, braces. Then you have 1 and minus 1 in the round brackets and end of the braces. So we have this as the solution of two variable using row operation on matrix. We will be using the row operation or Gaussian elimination to solve a system with 3 variables. So now we have x, y and z. X, y, z, 3 variables are there. If there were 2 variables, there were 2 lines. Now we are talking about plane. We are talking about where the 3 planes meet. What is the solution? X and y, x, y and z. So you need to assume it or anticipate and visualize it in the 3D form. 2 variables means you need to have just an anticipation of 2 lines intersecting. Here we have plane intersecting. So we'll find out made the augmented matrix. So 2, 1 and 3, these are the coefficient of x. So just first column will be 2, 1, 3. Second column will be negative 1, 2 and minus 2. That will be your second column. The third column is negative 1, 3 and 1. That is going to be your third column. Put a vertical bar and whatever is on the right hand side, 5, negative 2 and 2 has to be written here. Now this is your augmented matrix. Now we have to form echelon. That is, we have to make it in an echelon form. So first 2 is there. First row, first value is 2. We have to make it as 1. Then the second row, 1 has to be made 0 and 2 has to be made 1. The third one, 3 has to be made 0, minus 2 has to be made 0 and 1 has to be made as 1. So basically, we are talking about if one plane and second plane you draw, or second plane, one plane you draw, the intersection point or the common point or common line will be there. It doesn't change. So we are changing R1 and R2 exchanging. Why? Because we need 1 in the first row. This is the requirement of echelon form. So if we just exchange the row, we get 1. Now we have to make 2 as 0. The first value of the second row has to be made 0. And we will use the other rows to actually solve it. So the row 2 has to be added with negative 2 multiplication of row 1. So 2, when we add 2 with negative R1, you get 0. You also want to get 3 as 0. So what you will do is, you will multiply the first row with negative 3 and add with the third row. So you'll get 0 also. 2 as 0, 3 as 0. So leading first value of the second row, 2 has to be made 0. The first value of the third row, 3 has to be made 0. So what we did, minus 2 R1 plus R2, we made 0. Then minus 3 R1 plus R3, we made second value. That is the first value of the third row as 0. So we are actually making it as the echelon form. Still not done. But now we see that the third row, we have 8, 8, 8, 8, 3 8s basically. So I told you, if you exchange the rows or exchange the planes, it doesn't matter. The intersection point or the line will remain same. Okay. So what we'll do here, we'll do one thing. We will exchange the rows, second row and third row. So when we exchange, we get the second row as negative 8, negative 8 and 8. So now we are getting 1. How? We will multiply the second row with minus 1 by 8. When you do this, minus 1 by 8, what do you get? The second row will be 0, 1, 1. But we are not interested in the third one. We are interested in 0 and 1. It has to be 0 and 1 because 1 has to come at the diagonal of the first, from the first one. Now we have to make this minus 5 as 0, minus 7 as 1. This is the requirement of echelon form. So let us multiply the row 2 with 5 and add it to row 3. So we'll get a 0. In place of minus 5, you'll get a 0. And similarly, other value will be, you know already how it happens. Now still we have a negative 2 here. Now this negative 2 has to be made as 1 because we want an echelon form. So how to do is, just multiply it by minus 1 by 2. So you get a 1 here. So final this you can say a matrix, augmented matrix, has now taken a shape of echelon form. 1 in the diagonal, 0 below the diagonal. But still we are not still at the solution, because the next one is we have to make the equations. Remember, first column was x, second column was y, and third column was z. So we'll use the exponent, the coefficients, and we'll use it. 1 into x, let me just clear and write it here only so that you understand. See, solution is not yet being achieved. 1 into x plus 2 into y plus 3 into z equals -2. First equation. Second equation, 0 into x plus 1 into y plus 1 into z equals -1. So just forget about 0 into x. Third one is 0 into x plus 0 into y plus 1 into z equals -2. So x and y are eliminated, z equals -2. Now just take z equals -2, put it y here, y plus z equals -1. So you have y minus 2 equals -1, y equals 2 minus 1, y will be equal to this value you got. Okay. Now just put this value into x plus 2y equals 3z equals -2. We get the value. So z already we know, y we got as 1, and now with the usage of x, y and z, you can easily find out the value of x. So now you got the value. First we made the augmented matrix, then we change it to the echelon form, that is the Gaussian elimination, and then you got x, y and z value, and then we have solved the equation or system of equation with 3 variables using the row operation. Answer is 2, 1, -2. So this is how you are going to solve it. Okay. So this is basically where these 3 planes intersect. Along with this, we have to understand the inconsistent or dependent system. I'll give an example. For example, we have -3x plus 2y equals 7 and 9x minus 6y equals 15. We are making the augmented matrix. So let us make the augmented matrix, the coefficient of x, coefficient of y in the 2 columns, and with a bar, and right hand side we have 7 and 15, which is actually the constant. Previously we have already seen that the determinant of a equals 0 or not, that will define what is the inverse or not. But that is a different aspect here. This is the augmented matrix, and we'll try to make it as echelon form. So echelon form, we need -3 to be made as 1. So multiply the first row with -1 by 3. You get a 1. Now what you have to do, this 9 has to be made as 0. This has to be made 0. So just multiply this first row with -9 and add it to the second row. You get a 0, 0. So what do you get? So we have the equation which we can form. But the thing is that if you actually make an equation here, that is x plus y into -2 by 3 equals -7 by 3. And the second equation is x into 0 plus y into 0 equals 36. It is basically 0 equals 36. I'm just showing you how to solve it. I know you will be able to solve it. Just go to the concept, because you will have multiple questions to solve it. I hope you understand the concept. The concept is, when we try to make it as the echelon form, which I'm actually making while I'm speaking, this second row is actually giving you 0 equals 36. So x into 1 plus -2 by 3 into y equals -7 by 3 is the first equation. 0 into x plus 0 into y equals 36, 0 equals 36, which is not true, which is false. So that means these equations are inconsistent. We have no solution. The solution set is actually null, or you can represent it by phi. This is the inconsistent linear equation system. One more thing you have to see is the dependent system. Same thing we are going to do. This is the 2 equations I'm showing you. We are going to make the augmented matrix. We'll try to make -12 as 1. We'll try to make as 3 as 1 and -2 as 0. We'll do all the operations that you already know. But when we get the final echelon matrix, we have 0, 0, 0 in the second row. What does it mean? 0 into x plus 0 into y, second row I'm making, equals 0, 0 equals 0. And that is true. That is not false. So we have 2 equations, x into y into -2 by 3 equals -7 by 3, and 0 equals 0. So since 0 equals 0 is true, these are dependent equation. And this dependent equation, 3x minus 2y equals -7, is actually dependent on the second equation, and we can just write it as x comma y equals 3x minus 2y equals -7. That is the actual solution. Okay, you just have to write this is the solution. These are the dependent system. So this is all about this discussion. Thank you so much. Take care of yourself.